Introduction, cubes, perfect cubes or cube numbers, properties of perfect cubes, cube roots, finding cube roots by prime factorization method, finding cube roots by estimation method. What is a cube? So as we all have studied in our previous classes that a three-dimensional shape with all edges equal is a cube. So what is a three-dimensional shape? Any shape which has three parameters like length, breadth and height. So that's a three-dimensional shape. And cube is that three-dimensional shape where all the three parameters are equal in length. That is, length is equal to breadth is equal to height. So the best example of cube that you can think of around you is the dice which you use while playing Ludo. So when you look at the dice, you would see that all the sides are equal in length. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges we can see. There are 3 more edges which we can't see. So one would be here, there would be one from here, there would be one from here. So we cannot see those edges. So all the edges are equal in a cube. In fact, if you look at the Rubik's square, this one, which we normally play with, so there's a puzzle with different colors and then you need to rearrange them to make it this Rubik's square. So this is also an example of a cube. Now, we all know cube as a three-dimensional shape, as an object. So when it comes to a cube, we see that there are many different surfaces which make a cube. Like each face of the cube is a square. So when you look at it as a box, so when you think it like a box, you see that each face of the cube is a square and almost 6 squares together form a cube. Now the question is, how is cube related to numbers? So here we are not going to talk about these cubes. Here we are going to talk about cube numbers. Now there are some special numbers which are capable of forming a cube. So sounds weird? Okay, let's look at it in this way. How do we find the volume of a cube? Now, there exists cube of many different sizes, right? So, how do we know how big a particular cube is? By knowing its volume, right? So, volume tells us how much space that entire cube occupies. And how do we calculate that volume? So, let's take this example. So, in the first case, this is our first scenario where we have just one cube. And let's say that the length of each side of this cube is 1 centimeter. Now in a cube all sides are equal. So each of these sides measure 1 centimeter. So what would be the volume of this cube? How do we calculate volume? Volume is side into side into side. So here all the 3 sides are equal. In fact, for any cube all the 3 sides would be equal. So what is the volume? 1, that is the length of each side multiplied 3 times. Right? So when we multiply 1 3 times, we can write it as 1 to the power 3. So 1 to the power 3 is nothing but 1 cube. And 1 to the power 3 is equal to 1 centimeter cube. So the volume of this cube is 1 centimeter cube. Now let's look at the second scenario. So in the second scenario, let's say that we have these kind of cubes, but multiple number of such cubes. Like here you just had 1 cube and the volume of 1 cube was 1 centimeter cube. Here instead of having 1 cube, how many cubes you have? This is cube number 1, cube number 2, cube number 3, cube number 4, cube number 5, cube number 6, cube number 7, and again at the back side you have cube number 8. So here you have a total of 8 cubes. So when you have these 8 cubes together, it forms a bigger cube. Why? Because now the length of each side is not 1 centimeter. Instead it is 1 plus 1, that is 2 centimeter. So the length of each side of this cube is 2 centimeter. So what would be the volume of this cube? So the volume of this cube would be 2 into 2 into 2. That is 2 cube, which is equal to 8 centimeter cube. Let's look at yet another scenario, that is scenario number 3, where you have even more number of cubes, but here also all of them together form a cube. So here what do we see? How many cubes do we have? Let's count. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And in a similar way, you have it at the back side as well. Right, so that's how you can count the cube. Okay, so total how many cubes? So another easier way of counting the number of cubes is you count layer by layer. So here you have 3 layers. So the first layer you have 1, 2, 3. Let's number 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 small cubes in one layer. So in 3 layers, how many total cubes you have? 9 into 3, that is 27. So 27 small cubes together again form a bigger cube. This time the side length is 1 plus 1 plus 1 centimeter, which is 3 centimeter. So what is the volume of this cube? So for this big cube, the volume would be equal to 3 into 3 into 3, which is equal to 3 cube, that is 27 centimeter cube. Now what do we see? We see that there are only a fixed number of cubes. When you take 8 small cubes together, you get a bigger cube. Again, when you take 27 small cubes together, you get a bigger cube. Now let's say that instead of 27, if I give you 20 cubes, so can you think of any possible arrangement where by using 20 cubes, you will be able to get a bigger perfect cube? No. Every time you arrange those 20 cubes in any form, you will always get a cuboid, because with 20 cubes, you will never be able to have an arrangement where the height and the width and the length of the formation is equal. So sometimes the height will be lesser, sometimes the width will be lesser. So you will always end up having a cuboid. So that is why these numbers like 1, 8, 27, these numbers are called perfect cubes, or these are called cube numbers. Now here I have explained the concept by taking the analogy of the cube, that is the 3-dimensional cube structure. So now let us talk about the cube numbers in terms of numbers. So what are these numbers? So these are numbers which are obtained when a number is multiplied by itself 3 times. So any number which you can get by multiplying the same number 3 times. For example, if you take any number, think of any number that comes to your mind. Let's say you think of the number 52. So if you multiply 52 3 times, what do you get? It is 52 cube, obviously, and whatever value you get after this, so that value is a perfect cube or a cube number. So perfect cube numbers are also called perfect cubes. Why? Because these numbers are such that if you arrange these many numbers of cubes together, that will form a perfect cube. Like how you saw in the previous slide, that if you have 27 smaller cubes, you can make an arrangement which will form a perfect cube. Similarly, if you have 52 to the power 3 number of smaller cubes, you can again get a perfect cube. So that is why the name perfect cube. Okay, so let us look at the cubes of the first few numbers. So 1 cube is what? 1. 1 into 1 into 1. Similarly, 2 cube is what? 2 into 2 into 2. That is 8. 3 cube, 4 cube, 5 cube, and so on. And in these, which are the perfect cubes? Which numbers are the perfect cubes? So this number 1 is a perfect cube, 8 is a perfect cube, 27 is a perfect cube, 64 is a perfect cube, 125 is again a perfect cube. So each of these numbers, they are perfect cubes. Now you might ask that after 1, so 1 is like the first perfect cube, and after 1 you have 8. So what happens to the numbers that exist in between, like 2, 3, 4, 5, 6, 7? Now all of these numbers are not perfect cubes, because like you are cubing the numbers consecutively one after another. So after 1 you have 2, right? So you have cubed 1, you got 1. Now when you cube, you are cubing 2, you are getting 8. So that itself tells you that all the numbers between 1 and 8, they are not perfect cubes. Similarly, all the numbers which are missing between 8 and 27, they are also not perfect cubes. So these are some special numbers which are perfect cubes. So in this lesson, we are going to talk about these cube numbers or perfect cubes. Thank